Okay, so we are finishing up the lesson 3-2 notes with this very last example on the back. What does this mean? Second derivative. It is not anything squared. Alright, so we're finding the second derivative of this function. Okay, so instead of isolating y, I am just going to use implicit differentiation.
Does the bottom x on the two matter?
This too?
Yeah.
That's the way it's always written for second derivative. It bugs me, I don't like it, but that's what it means. Okay, so in order to find the second derivative, we must first find the first derivative. Okay, so using implicit differentiation, 6x squared minus 6y to the 1 dy dx. And the derivative of 8, what's the derivative of 8? 0. Okay. Okay, so let's isolate dy dx. I'm going to move this over to the right so that everything's positive.
Why did you have the dy dx?
Because we had to take the derivative of y, but I don't have this equation written as an explicit equation of y. So that's when we'd have to say just dy dx, whatever the derivative of y with respect to x is.
No, I don't take the derivative of x.
Okay, take the derivative with respect to x. That one is just 6x squared. But since I don't have an x in that one, that's why I have to tack on that dy dx. Okay? Okay, so I added that negative term over to the right. I'm going to divide by 6y. So dy dx equals 6x squared over 6y, which is just x squared over y. Okay, so that's the first derivative. To take the second derivative, what do we need? Quotient rule. Quotient rule. All right, so here we go. Next derivative, low. D high. Sure.
So we're low, D high,
This derivative. So we found the first derivative, but the second derivative is the derivative of this, so now we have to use quotient rule. So low D high minus high. What's the derivative of the bottom?
Just dy dx.
1 dy dx, or just dy dx. Okay, over y squared. Okay, so now what? Okay, check out this smooth move here. I know what dy dx is. It is that. Smooth, huh? So we're going to plug that in the place of dy dx. Okay, this is really over 1. When I multiply fractions, do I need common denominators? No. What is this product? Okay. And we're going to keep simplifying. Over 1. But in order to combine those two fractions, I need... What does my denominator need to be?
Y.
This one's going to stay. This one's going to be multiplied by y over y.
2xy squared over y.
Yep, that becomes 2xy squared minus x to the 4. They're both over y. Okay, who has a question? Okay, because I'm looking at these two denominators. I have to have common, so I'm going to make this denominator be y. But I have to multiply by a form of 1, so I multiply top and bottom by y. Okay, who else has a question so far? I've done a lot of algebra right there. Good. Okay, so now that I have common denominators, I can smush them into one fraction. Yeah, you could do your keep, change, flip, or your shortcut. And what do I end up with?
Y over 3.
2xy squared minus x to the 4 over y cubed. Do I need to go through any steps to show you how I got from that to that? Just nod if I do. Okay.
Alright, so my answer is the same as yours.
Okay, shoot.
432 XY
432? XY.
squared.
Okay.
I got the same variable.
Okay.
Minus 216 X to the 4th over 216.
What?
Y to the 3rd.
All right, y'all. So
432.
that divides by 216 and gives me the 1. Is 216 times 2 432?
That divided by 2.
Yes, it is. You just being extra special now.
No, I didn't mean to. I just didn't want to go back and think it all.
But it's equivalent, so that's fine.
Like at the first one, I didn't simplify the 6, and I didn't want to go back and do it again. I had already written it all down.
It's equivalent.
Will we ever have a problem with the second derivative involved by the x?
Mm-mm.
We don't have to plug it in.
No. Any other questions on that one? Okay, that was the shortest video ever for these guys. 7 minutes.